Hello, thank you for taking this course. First of all, I'm going to introduce myself and later then I will introduce this software to you. My name is Zabe and I've been working in an oil refinery for the last 10 years. I'm skilled in process simulation and modeling and I'm a certified process simulation user. I know Aspen Plus, Aspen Hysys, Pro 2 Aviva and Unisim Design. But today I'm going to introduce another powerful software to you, which is COCO. Uh, the softwares which I've already mentioned in my introduction requires a license, and that license is expensive for you to use. But this COCO software is free to use, and you can download it from its website, and it is readily available. So there is no issue with respect to license as far as this software is concerned to download. Okay, in this introduction I'm going to introduce the softwares, its component, its additional features and the conclusion. COCO is a CAPE open based steady state flowsheet simulation environment. During the studies, when you study the material and energy balance, there is a term which is also mentioned here, the steady state. So mostly it is being asked that what's the difference between the steady state and dynamic state when it's come to process simulation and modeling. Like when you apply the material balance equation, you see that there are three terms. The first one is the accumulation is equal to input minus output, means the material which is entering into any equipment or something like pipeline, vessels, columns, and the material which is now a product after being processed through the unit. So you put input minus output is equal to accumulation, but for the steady state you put or set accumulation to 0, so your input must be equal to output. So that's the material balance at the steady state. But when we talk about the dynamic state, there is an accumulation term which is with respect to the time. So you see the flow rate which is entering into the equipment and after being processed and become a product, you consider the time in the dynamic state. So that's the basic difference between the steady state and dynamic state. So this software is a steady state based flowsheet simulation, and it's COCO, it's CAPE open, and the figure here is showing that the overall process model consists of these three things. The one is the built-in submodels, user submodels, and third party. Like when you install a software, you see in the support folder that there are various examples solved for you. So that's the built-in submodels. And for example, you have given a task to separate methanol from water, so you put a separator in a simulation. So that's the user submodels, means that the work you will perform on the software. And the third party is the supporting softwares which can be linked with the COCO, or the COCO can be linked with those softwares. So that's the third party submodels. Okay, so COCO is a open platform softwares, and it also achieved an award in 2006, and it requires Microsoft Windows. Either you are using Windows 7, 10 or whatever the version you have, you can easily download this software and install it, and you can easily start using it. So its components consist of 4 external softwares which is linked with this main software. So when you start installing the software, you will see that there will be 4 icons appear on your desktop. So the first one is the flow sheeting environment, which is the first one main, which then be linked with this other 3 sub models. So this is the main environment, and you will start working on this flow sheeting environment, and then you will import the thermodynamic packages like Pang, Robinson, Model, Wilson, Coffee, and Unifac, and other thermodynamic packages you can import in this environment. And the set of unit operations like mixer, reactors, columns, separators, you will also import that unit operation into the main flow sheet. And for example, you have a reactions, and like you want to perform a combustion or something, chemical reactions you have, then you can use this reaction package manager. Like for example, when benzene reacts with hydrogen, it forms cyclohexane. So you can put that reaction into the reaction manager and import that reaction into the main flow sheet inside the reactor. So next is the some details related to the coffee environment, and this all contains the things which I have already discussed in the previous slides. It's built-in property calculators, and you can perform multiple streams and complex process flow diagrams into the software. It's OLE support. You can link with the Microsoft Excel with the main flow sheet. You can perform the calculations in the Excel and then export that calculations into the software. You can also perform some automations here. So this is the environment of the software. So you can see that there are multiple heat exchangers showing stream in and out, a complex plant structure here, and the graphical representations with the bubble point, dew point, and some more properties you can see through graphical pictures into the software. You can import the results into the main flow sheet, as well as you can export the results into the Excel sheet. Like this, you can see that this simulation results is being exported into this Excel sheet. You can use the software built-in graphs, or you can use Excel based graphs to show your results. Representation is good for the software. So the thermodynamic package details here, what kinds of thermodynamic package are there and how to import it. Like you can see that TI exports more than 25 different properties with their pressure, temperature, and composition derivatives. So you can import from TI different binary interaction coefficients and various models as per the requirement. You can also create a pseudo components and link different other softwares with TIA like CAMSAP. The third one is the unit operations. So you can import all kinds of unit operations into the main flow sheets, which includes compressors, pumps, turbines, expanders, simple reactor models, heaters, heat exchangers, mixers, and splitters. This software provides you all the necessary requirements for the simulation, as if you compare it with any high level softwares like Aspen Plus. So there are different versions in the market for this software. I suggest you to download the latest one. So the fourth one is the Cape-Open reaction numerics. So as I discussed earlier, that if you have a reactions in hand, then you can create a reaction environment and then import it into the main flow sheet inside the reactor. Some additional features of this software also include third-party contributions like CapSap and Aspen Plus have utility to import the COCO results into the main flow sheet. So this is some details related to this software, and I have summarized the features here. So somebody did an investigation on the COCO software, that how good its results if we compare it with the world-class licensed softwares like Aspen Plus. So the user first performed the same simulation in the Aspen Plus, then used the same data of Aspen Plus into the COCO, and he got the same results as in the Aspen Plus. So COCO is one of the powerful tool to use in the process simulation and modeling. So if you don't know that what is process simulation, then process simulation is a kind of hypothetical model before going on a real environment work in the field. So it not only saves your time but also the money. Like, your hypothetical model is developed first before the actual execution in the field. So that's why the process simulation modeling is very important, and you must have these skills if you want to become a process engineer. So you can download this COCO software from this link. It's free and easily available. And to conclude this introduction of the software, you should be proud of learning this COCO software, because it's an award-winning simulation environment that is entirely based on Cape-Open, allowing developers and industry to fully test and exploit the power and versatility of Cape-Open technology. It also contains all requirements for basic steady-state flowsheet simulation and is therefore suitable for academic use and educational courses on thermodynamics, reactions, separations, and process design synthesis. Okay, so what I'm going to teach you in this course, I will explain the working environment of the software, then we will move towards building the simple flow sheet of flash separator. Then I will show you that how you can use the unit operation pump, compressors, heat exchangers, distillation columns, and then we will move to build an integrated models which consist of 2 or 3 unit operations. So I would like to request you to install this software and then move to the lecture 2. Thank you.